An inspector noted a 100 amp panel might exceed the number of circuits and has piggyback circuits. This raises some important questions about electrical safety. Firstly, the inspector noted that the 100 amp panel exceeds the number of circuits. This likely means that more circuits are connected to the panel than the panel is designed to handle. The inspector also observed piggyback circuits, which refers to two circuits connected to a single breaker. This practice is not recommended as it can lead to overloading and possible electrical fires. Secondly, consider these possible issues. Overloaded electrical panels. If the number of circuits connected to the panel exceeds the panel's capacity, it can cause overheating and potential damage to the wiring and appliances. Thirdly, piggyback circuits can create an electrical hazard, as they can increase the risk of short circuits and electrical fires. To determine if the electrical panel is overloaded, perform the following calculation. 1. Add up the amperage of all the breakers in the panel. The total is approximately 415 amps. 2. Compare this total to the amperage rating of the panel. The panel is rated for 100 amps. If the total amperage of the breakers exceeds the panel rating of 100 amps, this indicates an overloaded panel, which is a potential safety hazard. If the total amperage is less than or equal to the panel rating, the panel is not overloaded, and there is no immediate safety concern. Based on the inspector's observations and the calculations, it is recommended to hire a licensed electrician to verify the electrical system and address any issues they may find. They can perform a thorough inspection, including inspecting the panel for proper wiring and connections, verifying the amperage of the panel and breakers, removing any piggyback circuits, and upgrading the panel or adding a subpole if necessary. It is important to prioritize electrical safety. By addressing these concerns, you can ensure a safe and reliable electrical system for the property. Let's delve deeper into understanding the concepts and calculations involved in assessing an electrical panel's load. The primary concern revolves around ensuring that the electrical panel is not overloaded, which could lead to overheating, damage, and potential fire hazard. Understanding these aspects is critical for maintaining a safe and efficient electrical system. Let's begin by defining some key terms. A circuit breaker is a protective device designed to interrupt the flow of electricity in a circuit when an overcurrent or short circuit is detected. Each breaker has an amperage rating, which indicates the maximum current it can safely handle. An electrical panel, also known as a breaker box or service panel, is a metal enclosure that houses circuit breakers. It serves as the central distribution point for electricity in a building. The panel has a specific amperage rating, indicating the total amount of current it can safely distribute. Overloading occurs when the total current demand on a circuit or panel exceeds its rated capacity. This can happen when too many devices are plugged into a single circuit or when the total amperage of all the breakers in a panel exceeds the panel's rating. Piggybacking refers to connecting two or more wires to a single terminal on a circuit breaker. This practice is generally unsafe and not recommended because it can lead to loose connections, overheating, and potential electrical fires. To determine if an electrical panel is overloaded, you need to calculate the total load on the panel and compare it to the panel's amperage rating. Here's a step-by-step guide. Firstly, identify all the circuit breakers in the panel and note their amperage ratings. These ratings are typically printed on the breaker handles. Secondly, for each breaker, determine the connected load in amps. This may require some calculations based on the wattage of the devices connected to the circuit. If the wattage is known, you can calculate the amperage using the formula amps equals watts divided by volts. In most residential settings in North America, the voltage is typically 120 volts for standard circuits and 240 volts for large appliances like stoves and dryers. Thirdly, add up the amperage of all the breakers in the panel. This will give you the total load in the panel. Fourthly, compare the total load to the panel's amperage rating. If the total load exceeds the panel rating, the panel is considered overloaded. It's important to note that simply adding up the breaker ratings provides a rough estimate of the load. In reality, not all circuits will be operating at their maximum capacity simultaneously. Therefore, Some electrical codes allow for demand factors to be applied, which reduce the calculated load based on the assumption that not all loads will be running at the same time. However, for a general assessment of potential overloading, it's best to use the full breaker ratings. Piggybacking circuits is a dangerous practice that should be avoided. When multiple wires are connected to a single breaker terminal, it can create a loose connection, leading to arcing, overheating, and potential fires. Additionally, it can overload the breaker, causing it to trip frequently or fail altogether. If piggybacking is observed, it should be corrected immediately by separating the circuits and connecting them to individual breakers, or by installing a subpole to accommodate the additional circuits. If an electrical panel is found to be overloaded, several options are available to address the issue. One option is to redistribute the load by moving some circuits to a less loaded panel, or by adding a subpanel to create additional capacity. A subpanel is a smaller electrical panel that is fed from the main panel. It allows you to add more circuits without overloading the main panel. Another option is to upgrade the main panel to a higher amperage rating. This involves replacing the existing panel with a new one that has a higher capacity. However, this may also require upgrading the service entrance wiring to handle the increased load. In some cases, it may be necessary to reduce the load by replacing old appliances with more energy-efficient models, or by limiting the number of devices that are used simultaneously. Regular maintenance and inspection of electrical panels are essential for ensuring their safe and reliable operation. Here are some tips for maintaining electrical panels. Firstly, keep the panel clean and free of dust and debris. Dust can accumulate inside the panel and create a fire hazard. Secondly, periodically check the breakers for signs of damage or corrosion. Replace any breakers that appear to be faulty. Thirdly, ensure that all connections are tight and secure. Loose connections can cause overheating and arcing. Fourthly, never overload circuits or panels. Be mindful of the total load on each circuit and on the panel as a whole. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician to perform maintenance and repairs. Working with electricity can be dangerous, and it's always best to err on the side of caution. Understanding the principles of electrical panel loading and safety is crucial for homeowners and anyone responsible for maintaining electrical systems. By following the guidelines and recommendations outlined above, you can help prevent overloading, reduce the risk of electrical hazards, and ensure the safe and reliable operation of electrical panels. Let's explore more detailed aspects of electrical panels, circuit calculations, and safety measures. This discussion will provide a more comprehensive understanding of electrical systems and how to maintain them effectively. First, let's look at National Electrical Code, or NEC standards. The NEC provides guidelines and regulations for electrical installations to ensure safety and prevent electrical hazards. It covers various aspects of electrical systems, including panel sizing, circuit protection, and wiring methods. Understanding and complying with the NEC is essential for electrical professionals and anyone working with electrical systems. Now let's talk about calculating circuit loads, which is crucial for determining the appropriate size of circuit breakers and conductors. The NEC specifies methods for calculating the load on different types of circuits, including general lighting circuits, appliance circuits, and motor circuits. These calculations take into account the wattage of the connected devices and the anticipated demand on the circuit. For general lighting circuits, the NEC requires a minimum load of 3 volt-amps per square foot for dwelling units. This ensures that there is sufficient capacity to accommodate lighting fixtures and other small appliances. For appliance circuits, the NEC specifies different load calculations depending on the type of appliance. For example, a small appliance circuit serving kitchen countertops must have a minimum of 220 amp circuits. For motor circuits, the NEC requires calculating the full load current of the motor and applying appropriate demand factors based on the motor's duty cycle and operating characteristics. Proper circuit protection is essential for preventing overcurrents and short circuits, which can lead to overheating and fires. Circuit breakers and fuses are the primary protective devices used in electrical systems. Circuit breakers are resettable devices that trip when an overcurrent is detected, while fuses are one-time devices that must be replaced after they blow. The NEC specifies the overcurrent protection requirements for different types of circuits and equipment. The size of the circuit breaker or fuse must be matched to the ampacity of the circuit conductors to ensure adequate protection. The ampacity of a conductor is its current carrying capacity, which is determined by its size, insulation type, and installation conditions. The NEC provides ampacity tables for different types of conductors in Article 310.15. Grounding is an essential safety measure that helps prevent electric shock by providing a low impedance path for fault current to return to the source. The NEC requires grounding of electrical systems and equipment to ensure that metal parts are at the same potential as the earth. This helps to minimize the risk of electric shock in the event of a fault. Grounding electrodes, such as ground rods or metal water pipes, are used to connect the electrical system to the earth. Ground fault circuit interrupters, or GFCIs, are another important safety device that protects against electric shock by detecting ground faults. A ground fault occurs when current leaks from a circuit to ground, such as when a person touches a live wire while standing on a wet surface. GFCIs are designed to trip quickly in response to ground faults, interrupting the flow of electricity and preventing electric shock. The NEC requires GFCIs in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Surge protection is important for protecting sensitive electronic equipment from voltage surges caused by lightning strikes, power line disturbances, and other factors. Surge protective devices, or SPDs, are installed at the service entrance or at individual circuits to divert surge current away from the equipment. SPD are rated based on their surge current capacity and their ability to limit voltage. Regular inspection and testing of electrical systems is essential for identifying potential problems and ensuring their safe and reliable operation. The NEC recommends periodic inspections by qualified electricians to check for damaged wiring, loose connections, and other hazards. Testing of GFCIs and FCIs is also recommended to verify their proper operation. Arc fault circuit interrupters, or FCIs, are designed to protect against arc faults, which are dangerous electrical faults that can cause fires. Arc faults occur when electricity jumps between two conductors, creating a high-temperature arc that can ignite nearby materials. FCIs are designed to trip quickly in response to arc faults, interrupting the flow of electricity and preventing fires. The NEC requires FCIs in bedrooms and other areas where there is a high risk of fire. Electrical safety is paramount when working with electrical systems. Always follow safe work practices and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Never work on live circuits unless absolutely necessary, and always de-energize the circuit and verify that it is dead before working on it. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Remember, electricity can be dangerous, and it's always best to err on the side of caution. Understanding these detailed aspects of electrical panels, circuit calculations, and safety measures is essential for maintaining a safe and efficient electrical system. By following the guidelines and recommendations outlined above, you can help prevent electrical hazards and ensure the reliable operation of electrical systems. Let's expand on our discussion of electrical systems by delving into specific scenarios and providing practical examples to enhance understanding. We'll cover various aspects, including load calculations, voltage drop, and troubleshooting techniques. Imagine a scenario where a homeowner wants to add a new electric vehicle, or EV, charger to their garage. The EV charger requires a dedicated 240-volt circuit with a 50-amp breaker. To determine if the existing electrical panel can handle the additional load, a load calculation must be performed. Firstly, gather information about the existing loads on the panel. This includes the amperage of all the circuit breakers and the wattage of any major appliances. Secondly, calculate the total existing load in the panel. This involves adding up the amperage of all the breakers and converting the wattage of appliances to amps using the formula amps equals watts divided by volts. Thirdly, determine the additional load of the EV charger. In this case, the EV charger requires a 50 amp breaker, so the additional load is 50 amps times 240 volts, which equals 12,000 volt amps or 12 kilowatts. Fourthly, add the additional load to the existing load to determine the total load in the panel. Fifthly, compare the total load to the panel's amperage rating. If the total load exceeds the panel rating, the panel is overloaded and must be upgraded or the load must be reduced. In addition to load calculations, it's important to consider voltage drop in electrical circuits. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause appliances to operate inefficiently or not at all. The NEC specifies the maximum allowable voltage drop for branch circuits and feeders. For branch circuits, the maximum allowable voltage drop is 3%, and for feeders, the maximum allowable voltage drop is 5%. To calculate voltage drop, you need to know the length of the conductor, its size, its ampacity, and the current flowing through it. The voltage drop can be calculated using the formula voltage drop equals 2 times K times I times D divided by Cm, where K is a constant that depends on the conductor material, I is the current in amps, D is the one-way distance in feet, and Cm is the circular mil area of the conductor. Once the voltage drop is calculated, it can be compared to the allowable voltage drop to determine if it is within acceptable limits. If the voltage drop is too high, you can reduce it by increasing the size of the conductor or by shortening the length of the circuit. Troubleshooting electrical problems is an essential skill for electricians and homeowners alike. When troubleshooting electrical problems, it's important to follow a systematic approach to identify the cause of the problem and implement a solution. Firstly, gather information about the problem. This includes asking questions about when the problem occurs, what devices are affected, and any recent changes to the electrical system. Secondly, inspect the affected area for any obvious signs of damage or problems. This includes checking for loose connections, burned wires, and trip breakers. Thirdly, use a multimeter to measure voltage, current, and resistance. This can help you identify faulty components or wiring problems. Fourthly, consult wiring diagrams and technical manuals to understand the circuit and its components. Fifthly, isolate the problem by systematically testing different parts of the circuit. Sixthly, implement a solution by replacing faulty components, repairing damaged wiring, or correcting any other problems that are identified. Safety is paramount when troubleshooting electrical problems. Always to energize the circuit before working on it, and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable troubleshooting electrical problems, hire a qualified electrician to perform the work. Consider a scenario where a homeowner experiences frequent tripping of a circuit breaker in their living room. To troubleshoot the problem, the homeowner should firstly gather information about the problem. They should ask questions about when the breaker trips, what devices are connected to the circuit, and any recent changes to the electrical system. Secondly, they should inspect the living room for any obvious signs of damage or problems. This includes checking for loose connections, burned wires, and damaged outlets. Thirdly, they should use a multimeter to measure the voltage and current in the circuit. This can help them identify if there is an overcurrent or short circuit. Fourthly, they should consult the wiring diagram for the living room circuit to understand its components and connections. Fifthly, they should isolate the problem by systematically disconnecting devices from the circuit and testing the circuit with each device disconnected. Sixthly, they should implement a solution by replacing faulty devices, repairing damaged wiring, or correcting any other problems that are identified. By following a systematic approach and prioritizing safety, homeowners and electricians can effectively troubleshoot electrical problems and ensure the safe and reliable operation of electrical systems. These practical examples illustrate the importance of understanding electrical principles and applying them to real-world situations. By mastering these skills, you can maintain a safe and efficient electrical system in your home or business.